Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about SpaceX speed. So let's dive right into it. So we have to understand one thing about SpaceX. At this point in time, when I'm making this video, they have already beaten every single space organization on this planet. Now, I'm very specifically dividing space organization in two core categories. One is the payload division, basically the satellites you make, the rovers you make, the instruments you build. That is one. Second is actual rockets that actually take your stuff into space. Now, in that space division, flat out, there is no competition. At this point in time, they are the only company that they have first stage reusable. They basically, other people did try that, like for example X-33 was a test vehicle for this exact purpose, but it failed. Failed or abandoned would be better word for that, but you get the point. Nobody had thought it could be even possibly done, or it was worth doing it, but they did it. And flat out, they are the only company. While me making this, hundreds of companies are saying, no, we're gonna do this, we're gonna do this. They are the only one who have done it, past tense. Then we come to another aspect of it, which is a very giant milestone. It's all good and dandy to build a rocket that can put satellite into space. It's a completely different matter to take human life in your own hand. And to give you a context, worst example thing ever built by humans for human carrying was space shuttle. It took 14 people bit up, and it was a tragedy. Flat out, it was tragic because it had no emergency escape system. So building a rocket that is human rated after a space shuttle requires a much more calibration, much more thorough testing, much more fail safe on top of fail safe, and it has to be designed in such a way that even in worst case scenario, you make sure the people basically can walk out alive. That's why, like, we have 3 parachute. One can barely do it, 2 is more than good enough, 3 is done just so make sure that if you have 1 parachute failure, you still get basically safety of life, which was tested accidentally in basically Boeing testing, because they did deploy 3 suits, only 2 deployed successfully. So you get the point. Making a craft after a space shuttle that is human rated by NASA standard is very difficult, and they have already achieved it. They're like, dude, we got this, we're done. Past tense, go home. And be mindful, this is the same time Boeing should have been also done. Like, NASA was planning on that. They would have 2 vehicles to use, but at this point in time, Boeing is at bare minimum 1 year behind, at maximum, practically speaking, 2 to 3 years behind. So, and do not even dare to compare the budgets of these 2 giants. So flat out, they have achieved things that thought impossible, achieved things that was too goddamn difficult for giants as Boeing, and they only started in 6 May 2002. So they are barely 19 years old, and at this point in time, they are the cheapest. Now, you may find other companies that are building rockets that are like, say, $5 million, but you have to understand one core aspect of it. You have to compare it against tonnage. So if you go to SpaceX, it's like, bro, I need to send 10 tons, 15 tons. At that point in time, they're like, dude, we are the cheapest option out there on the planet. The end. There is no discussion about that. Now, if you are like, hey, I'm only sending 1 small satellite, let's say NOAA satellites or things of that nature, just to low Earth orbit, yeah, other side providers are there that will give you lower cost, but per ton wise, they are the cheapest. Then we come to the another aspect. They are fastest, means like, you go to them, it's like, dude, I need you to book yourself for one of my satellite launch. They're like, when do you want? Now, most of the time, most of the government agencies, other private companies, they're like, book us advance minimum 1 to 2 years. SpaceX, yeah, we have a seat available next month. That's how fast they are. They are idiotically fast. Basically, if they want the rocket to be launched tomorrow, it can be done. They are that quick at this point in time, and this allows them to have idiotically high throughput. At this point in time, they alone manage to do what every other basically satellite phone provider, satellite internet provider failed to do, simply because of their high throughput. There are many companies that try to make satellite internet, satellite mobile phone a thing. All of them failed for one simple reason. They could not get enough satellite quickly enough into orbit where they can cover the whole planet and be like, no, we have awesome service anywhere in the world. Because they had a scenario where it's like, they have few satellites, the coverage quality is very basic, so they're like, please buy our service, then we can use the profit to sell more service. That never works out. You always have to start with a good solid network. Starlink already exceeded 1000 satellite, flat out. They exceeded it. There are very few countries that can even say that had 1000 orbital launches. So throughput wise, they are on a whole another level. There is no discussion. Like, to give you a context of that, space shuttle, when the idea was pitched to Congress, the idea was they're gonna be launching 2 of them, basically 2 space shuttle launches per month. That was the aim. They barely managed to do 2 space shuttle launch per year, barely. And SpaceX, they are almost at a point where they are reaching almost weekly launch. So there is no competition when it comes to throughput. They are way ahead of every single company on this planet. So how the heck they achieved this magical thing? Ironically, simplicity was their key. So SpaceX is driven by Elon Musk. Now, Elon Musk, no matter what you think about it, he has a bit of passion towards him. He's not just like, I'm doing a job. No, I'm doing it with passion. So what does that translate to? That translates to he has a different approach. Primary being, if things are not failing, you are not innovating enough. Now, this alone granted them an advantage that no other companies have. For example, if you take USSR and NASA, they were doing amazing things, flat out god tier technology when they were under threat of war. During Cold War, they were pouring money like there is no tomorrow. They were building technology like we still could not replicate. Like the amount of blood, money, sweat poured into this technology, they were god tier level. Now, what happened after that? The moment USSR were dissolved, what happened after that? The money ran down and they relaxed a bit. Now, what happened to every third tier countries that were like they were in the race, they were building their space capability? What happened to them? All of them also calmed down. They're like, yeah, let's buy the engine from there, let's buy an engine from there. Like India itself has a bought engine from France and Ukraine. You get the point. Basically, every country is just like, hey, can I buy from NASA? Can I buy from Russia? Can I buy from this and that? And they're just not tampering with it. It's just like, we got a working technology and we are not tampering with it because it works. Let's not break it. Now, Elon Musk on the other hand, why the heck all of you are using 1970s technology? So, and inherently, even to his engineer, like for example, Merlin engine was not regeneratively cooled in the first generations. They did not have the money for it, and they were using ablative cooling. So they had to figure some tricks, tips and tricks out, and that helped them a lot. And because they had a lot of issues. For example, Falcon 1. Three of them failed, 3 or 4 of them failed, and but they still had a simple approach: make it, break it, and repeat. They were not like make it and make it work. No, it's like make it, something broke, okay, let's fix it. They were not afraid of like less tampering with things. They were like they were not in that middle class attitude where it's like, I bought this, but let's baby this thing. They are like, we bought this, let's utilize this to its absolute extent. It breaks, okay, how can we make it better? So that approach flat out gave them the luxury that no other basically company can achieve, and they simplified everything. For example, this rocket, there are many companies and countries that have something similar, like India's PSLV. But here's the deal: PSLV has 4-stage rocket. This is just a 2-stage system, and almost every rocket on the planet, for some reason, have multiple types of engine in a single rocket. For example, there would be Merlin and something different here. Now they did try that, but then they simplified it. That's what I'm saying. Like they will start out things, and they're like, you know what? We really should not do that. That's not simple enough. They will simplify it. And that's why Falcon 9 only has one type of engine. You compare this to any vehicle provided by ULA, Boeing, or NASA, or ISRO. Most of them have like different kind of engines in different kind of stages. That's really bad for mass manufacturing. Flat out, Elon Musk is, let's simplify all that. All we have to redesign is just nozzle for it. And they built one rocket, Falcon 9 Block 5, to rule them all. And flat out, on this moment in time, there is nothing that even comes close to this. Like their only Achilles heel, you can say, is the fairing is a bit too small. Now I will explain why that was an issue, but right now that's the only thing they are modifying, is like they are re-engineering the Falcon 9, the upper parts of it specifically, just so they can put a larger fairing for Air Force. So that's the only thing you have to understand. They built one rocket to rule them all, and flat out at this moment everybody failed, simply because go to ULA, they have a catalog, go to ISRO, they have a catalog. The moment a company has a catalog, they failed, because they only built one rocket and they made sure this is the most goddamn awesome thing out there. You can compare this to Apple versus Samsung. Why the heck Samsung, while it has much larger portfolio of, in terms of like they actually own container ships, military vehicles, why the heck they do not have multi-trillion-dollar valuation like Apple does? Simply because Apple has products, while Samsung has product lineups. Basically, you count the products of Apple, you will count product line in Samsung division. Basically, like for every iPhone, there is a whole product lineup in mobile division. Inherently garbage output, inherently. So that's the whole point. Simplified it. And then we come to the king of them all, Falcon 9. Now, Falcon 1 was very amazing simply because that was the proof of concept, and that was built by Elon Musk from his own money. He did not have luxury from anywhere else. Like he has like, dude, I have to prove this. I have to build this, because without it, they would not get, they would not even be in the race for the contract of basically building Falcon 9. So flat out, everybody's saying like, no, NASA paid them. No, NASA was like, dude, prove me. And be mindful, there were many companies that tried to bid for this war, and most of them failed flat out. And even Boeing was the finalist. They were still like so behind in schedule that SpaceX was looking like they were generations ahead. So fundamentally, Falcon was the most amazing achievement they did, because few people, and that's it. There was nothing more than that. Like few people, few millions of dollars, that's it, done, go home. And then they designed Falcon 5 to have more capabilities, and then they did something most companies never dare to do. They flat out killed Falcon 5. They flat out killed Falcon 1, and they put 100% of their attention on Falcon 9. And this is the moment history was made. the end. This is the moment. Basically, if you go to every other company, most of them build underpowered rocket, and then they're like, let's strap on this booster, then strap on this booster, and then some more boosters and some more configuration to get like, dude, just build a goddamn bigger rocket. And this was the most amazing decision they made. They're like, dude, Falcon 5 is too weak. Falcon 1 is barely usable. Why we are focusing on those two things? That's the moment. That was the genius of them. It's like, hey, we can make one bigger rocket and we can underpower it, but you can't overpower a underpowered rocket. But you may say, like, I can strap on booster, but that increase your cost exponentially. That's why every other rocket company is like, yeah, don't even talk to us unless you are talking about $125 million. And this guy's like, $25 million, take it and go. Don't worry about it, take it and go. So that's the whole thing. At this moment, when they made that decision, Falcon 9 would get their 100% of attention. They became the successor. And Falcon 9 was improved continuously. Like if you look at the Falcon 9's first generations, they were barely able to put 10 tons to 12 tons into low Earth orbit. While still good, it was not great. It was like, okay, good, but like it was like, whoa. So what happened after that? They did something another amazing. They did not stop. Basically, at this point in time, the moment any other company would have gotten Falcon 9, they would have stopped. It's like, dude, we got this awesome thing. Everything is awesome. Don't tamper with it. SpaceX, if you're not breaking it, you're not innovating it, they're like, let's keep improving it. And the only moment they decided to stop is basically once they had maxed it out, and they're like, theoretical output of this system versus their practical output, they are almost touching. They inherently do not have any theoretical basically optimization left. They can't do much. So that's why they have stopped it. And once they got the manned rating, tampering with it becomes impossible, simply because you have to redo the entire procedure for manned rating. So they're like, okay, that was a good point for them to stop development. And once they had done with that, the only thing they are changing right now is the fairing, and that's only because of basically Air Force request. So be mindful. This decision, basically you can see from original Falcon 9, it has engines in like a grid pattern and not octagon pattern. Why the heck that changed? It was more efficient, more easy to manufacture and fine tune. So fundamentally everything they changed. Like you can look at example of original grid fins. They melted a lot. Like you can see there are pieces missing of that, simply because they were making they used the best aluminum alloy, but it was not strong enough. Then they switched to titanium, and heck, you can type Falcon 9 grid fins. You will find some of them has bolted on segments in there. Basically they were trying whether you can repair it or not. It did not work out that well. So you get the point. Like they kept changing it. It's like, let's make it more efficient. That's why it started with 10 ton, ended with 22 tons. That's amazing. They changed everything from designs, improvements, and they not only changed the rocket, they also made it more efficient in terms of reusability. Basically, okay, if this part, is it easy to repair? No? Okay, then change it. Even if this is the best thing, and the thing we are replacing it with is crappier compared to main thing, they did it simply because it made the things more serviceable. And that was the biggest issue with Space Shuttle. Space Shuttle was amazing. It's just like servicing it was like a nightmare. So that's the amazing thing. The moment they gave undivided attention to Falcon 9, where they're like, kill off Falcon 1, kill off Falcon 5, and they had a big period where they're like, dude, make sure Falcon 9 is there because we have no basically fallback. That was the amazing decision. And the fact that once they completed a Falcon 9, once they got the NASA contract, they still did not stop. They're like, dude, let's keep working on it. That made sure that there is no other company on this planet that can even come close to this. Oh, by the way, the same time Blue Origin was doing suborbital launches, they are still doing that. Now we come to Starship, and SpaceX is repeating what they did earlier. Is less like one rocket to rule them all. They're not building Starship this or Starship that or XL variant or that variant. No, just one goddamn rocket. Don't overthink it. Just like simplify it. Don't overthink it. And it's a two-stage reusable rocket. Simple. It's just like last time they had only single stage reusable. This time both stages are reusable. Nothing fancy. It's just like a continuation of their evolution. And they are doing the most amazing thing. It's like single type of engine, single Raptor engine. That's it. Like, so that simply translates to the factory have to only make Raptor engines, nothing else. Raptor and Merlin. And to give you a context, there are many rockets that have more than that, which are much more inferior to Falcon 9, not even think about comparing to basically Starship. So this whole decision that we're gonna change nozzle rather than the whole engine gives them an advantage. And they already had like big grand plans. Like if you look at the original BFR concepts, it was a bit too bonkers. It was like, bro, how high are you? It's like 300 ton to low Earth orbit. I'm like, that's almost International Space Station in one go. That was like a bit too bonkers. But then they're like, okay, that requires carbon fiber. Carbon fiber is idiotically expensive and ludicrously difficult to manufacture. They learned from their mistake and they went to stainless, and that simply gave them an advantage. Now they are cheaper and efficient. Now efficient in terms of rocket, no, efficient in terms of manufacturing it. Compare that system to, let's say, ULA's Vulcan rocket, that is the next generation rocket that should also utilize methane and all that. You take an aluminum plate. Okay, so far so good. Aluminum is a bit expensive than stainless steel, but not that expensive. Okay, everything's good. Put that into a CNC machine to mill out that isogrid. Yeah, you lost all your $25 million just there. Just that process, just to take that aluminum panel and then mill the isogrid, then bend the system. Yeah, good luck with that. Good luck trying to make that process cheap. And not to mention, you have to recycle all the aluminum that you wasted, because you started out with a plate that was a 1 ton and then you milled out almost like 90% out of it. That's a idiotically wasteful approach. SpaceX approach, just bring out aluminum, basically a stainless steel roll, and then make a spiral out of it and then weld from the inside. Nothing, done, go home, sweet dreams. So flat out, that is the efficiency aspect of it. And that's why no other company right now that are even building anything that can come close to the price point of this. Similar building structure is service, like that isogrid itself costs money. SpaceX is like, struts are much easier to build inside. Yes, they are not as efficient as isogrid, but they are efficient in terms of manufacturing cost and time taken. So flat out, amazing decision. And this time they are utilizing large diameter for capacity, so they will not have the issue of basically once they have finalized everything, once they have maxed out the project, they're like, no, please change the fairing size. That won't happen. And the reason why Falcon 9 has a singular flaw, it's way too skinny. Now you may be like, why the heck rocket is skinny? People sometimes forget that NASA is giving them money on a basically milestone basis. It's not just like, okay, here's your budget, take it and go. It's a milestone basis. Basically, achieve this, then we're gonna give you this much. Achieve this, we're gonna give you this much. That means they have to be very efficient with the money, which Boeing is not. That's why like Boeing is in billions of dollars and when SpaceX is like in millions of dollars. So to achieve transportation of their rocket from point A to point B, they made a decision that rocket should be able to transport it on normal roads without requiring special permits or finding a road that does not have an overbridge or things of that nature. Thankfully, US has a rule and regulations about that all bridge must have like this kind of clearance to attack. Now they made sure the rocket fits inside that clearance. Because of that transportation limitation, the rocket is a bit too skinny. And because now they have the money, and if things go accordingly to Elon Musk, by the end of 2022, there will be a point where they are making money from Starlink. And if the volume of their interest is correct, they will be printing money. At that point in time, they don't even have to worry about it. They're like, dude, we can make our own road, which Russia did do that. They have their own railway network from point A to point B to transport the rocket. So you get the point. That was a serious limitation. They had to make the rocket efficient, slim. Consequence was the rocket is not very efficient in terms of like how much oomph it can do. Engines are more powerful. It's just like the rocket is like, dude, we can't put big fairings on that. That's why they have to re-engineer the damn thing right now. So this time, big ass. They made the thick boy. They made it chonkas, just to make sure they no longer repeat the same mistake of the last time. And they have the money to afford the big cranes and bulldozers that is needed to move these things. Now your rockets are directly limited by the factories that produce it. For example, Boca Chica. Now if Boca Chica is a lame, slow ass place, your rocket is not gonna do anything better than that. So fundamentally, rocket production is directly limited by factory. And now in this, Elon Musk is doing something kind of unique. Now it's not like it's not done anytime before that, or the fact that people have tried the same approach and have found a serious drawback to that. But this time it worked. Basically, think of this way: Elon Musk took a gamble and it paid off. So idea is the factory is not made, the factory is grown. What does that mean? Think of it this way. If I give you a simplest example, basically something similar to this complexity. Let's say Boeing Airbus aircrafts, they started to build a new factory. I was watching this documentary on National Geography and they said something that was very unique to me. It's like they bought the land, they find the whole design. Okay, this is the plot of land, we got the land rights, everything is awesome. Then they started to design the system. I'm like, okay, how long that would take? It took them 18 months while utilizing the most advanced computer CAD softwares out there. It took them 18 months before anybody even touched the land, just to design the goddamn thing. Now compare that to Boca Chica. Boca Chica 18 months before and 18 months after. That's like mind-boggling. How the heck that happened? Because they are not designing it. They have a rough idea. They have like, okay, this is what we have to do, and they are going there and building it. Now this is the most amazing aspect of Elon Musk's approach, where they're like, let's build a full-scale model. Now many people are like, why you're building full-scale model? It's so wasteful. No, it's very amazing because A, there is no supercomputer right now made by humans that can come close to the real-world test. Another aspect is, it's the best testing methodology out there, because every other company is like, they will finalize everything and then they're gonna start producing it, and that creates the consequences, sunk cost fallacy. They can't change anything after that. It's like, dude, we burned through millions of dollars just trying to finalize this carbon fiber design, and now you are asking us to change it. Nobody would do that. But because Elon Musk is directly doing that, like, just build it, don't waste time on computers and quiet. Of course they have that. It's just like, compared to every other company that would take, let's say, 18 months, they are taking few months. So that gives them agility, and gives them, given the fact that they are building full scale models, they know how much things they need. Basically, that's why you will see people go there, they start building, hey dude, weather is not helping us, build a tent. Okay, they build the tent. Okay, how big the tent needs to be, they figure it out. Then they're like, dude, let's make it permanent. The people need this, let's make it permanent. That's why you will see basically booster being built, and then the casing around the booster, that is like the main hanger, is being built alongside it. Building in full size allows them to fine tune the factory, and because they are growing the factory, rather than just like, we started with a complete plan and we are working on it, they're like, it's a plan, a rough plan, of course is there, a rough plan is absolutely there. It's just like, let's figure it, like, which is important. Because they are dealing with full scale, they know, okay, we need to figure out roads, we need to figure out concrete pad, we need to figure out, like, because they are doing the full scale testing, they have absolute data points. So that is why the fact that they are growing the factories, it's idiotically fast. And the building the damn thing, and because of the huge size, they have side effects. They are like, dude, we have to figure things out, we have to solve this problem, and they are solving it, and the factory is efficient because of that. So one small step equals a very large speed for them. It's like, brick by brick, hey, first build the road, then build a parking spot, then build a tent for them, build a bathrooms for them, build out a bunker for them, then brick by brick. That's why they have like a freaking, all the basically disassembled basically starships are used for outside wall. Basically the fencing around that, it using same stainless steel was used for basically previous starships. Like, when what happens to starship once it go boom, it's like, yeah, the metal is scavenged and made into wall. Amazing. They're growing the damn thing. That's why it's so efficient. So this was my presentation on why the heck SpaceX is so fast compared to every other thing in this planet. So hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike. Press it twice to show me extra disappointment. Please leave a comment, because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.